Okay, here's a question from Alex talking about different phases and how we can maybe interpret some part of this curve. And so before we talk about this particular problem, let's look at a typical curve right here. We do have a typical curve. Okay, I'm just going to draw it just a little bit bigger, and I won't draw my lines straight. Okay, so we are going to start here as a solid. We're going to hit some sort of melting temperature. We're going to move across till we get everything melted. Then we're in the liquid phase right here. And then we'll hit the boiling temperature. And as we add heat, then eventually everything is going to go into the vapor phase. So this is temperature right here. And this is going to be the heat that we had. And so there are a couple of things I think that are important to keep in mind. When we look at these curved parts of the curve, or the slant parts of the curve, then these are going to be inversely proportional to the heat capacity, in this case for a liquid. Here we're going to be inversely proportional, that's 1 over the heat capacity of the gas, and then down here this is going to be inversely proportional to the heat capacity of the solid right here. Okay, so what does that mean? That means that as we have a smaller heat capacity, a lower heat capacity, that will have the effect of making this part of the curve steeper. Okay, it will make this, if heat capacity is lower, it's going to make this part of the curve steeper. It's going to make this part of the curve steeper. Okay, and the opposite is true. If the heat capacity is extended, it just takes more heat. It just takes more heat as heat capacity goes up, and so it's going to tend to flatten that part of the curve as the specific or the heat capacity then gets larger again, and just make this much more flatter, not totally flat, but flatter. So again, as heat capacity gets smaller, the curve gets steeper because it takes less heat. You just need a little bit of heat, and so it's going to steepen up that curve. If heat capacity is large, you need more heat, and that's going to then make each of those flatter. And so that's something to keep in mind as we're looking at these curves. Okay, another thing we're going to have to be interested in is the heats of vaporization and the heats of fusion. Okay, so again, this is easier to see. That is heat of fusion gets smaller, it takes less heat. And so that's just going to shorten up this part of the curve. If you have a smaller heat of fusion, you just don't need as much heat. As we keep adding heat, you just don't need as much until you get everything heated up and into a liquid. And so that's going to tend to shorten these parts of the curve, and vice versa. If the heat of fusion is greater, it's just you have to add more heat. It's going to tend to lengthen this out. Okay, and that's going to be true as well for the heat of vaporization. So as we answer these questions, it's important to keep this in mind. Okay, so let's now tackle this question. Okay, you have this substance that we're going to use as a comparator right here in the middle. Alright, and then we have two other substances. Here's substance Y. It has a lower heat capacity in the gas. And so if it has a lower heat capacity, remember it's going to steepen that thing up. Here's where, I can draw it over here. If here's where S is, then it's going to make this a little bit steeper. Okay, and substance Z has a higher heat capacity. It takes more heat. Remember, adding heat takes more heat, and so it's going to tend to flatten that out. Something like that, maybe. I am exaggerating that out. So let's actually go over here then to Alex, and let's see if we can answer this right here. So again, the lower heat capacity of the gas, I'm going to be looking up at this part of the curve, and it's going to make that part steeper. So let's look. That has a different boiling temperature. That's definitely not going to be it. Okay, looks to me like that steepened it up. So I'm going to say that this one is the one. I guess I should probably go through and look, but that's not it. That looks not it either. And that doesn't look like they changed the slope of that. So I'm saying that that's it right there. And then the stuff with the higher, again, it's going to just flatten that thing out. So let's find one that flattens it out. That doesn't do it. That one is the one. See how that's flatter? And so I am going to say that that's it. I'm going to check my Alex, and I got that one correct. So that's how you handle these graphs. It's actually not too hard once you understand what's being asked by our friend Alex.